Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 2 from Chapter 6, which is talking about multiplying and dividing rational expressions. Specifically in this video, we're really going to look at just multiplying rational expressions, and we'll look at dividing rational expressions in the next video. So we're going to continue on in our theme of pretending that we're dealing with normal, everyday fractions, rather than rational expressions that have variables in them. So let's look at how we multiply a simple fraction like 9 over 5 and 2 over 3. So what we would normally do here is that we would multiply straight across. So we multiply the numerators together and then the denominators together. That would give us 9 times 2 over 5 times 3. Now some of you might go ahead and just multiply the two numbers, like your two numerators together, your two denominators together. But what I would recommend is, especially when we're working with rational expressions, is that we're going to reduce before we multiply. And this is something that you should have learned in elementary school. Whether or not you remember it is, I guess, another question. But what you can do first, though, is we can reduce numbers. And I actually prefer this way because then it's really easy to see what numbers are in common. So here we have a 9 and a 3. Those can be both divided by 3. So if you divide 3 by 3, you get a 1. And if you divide 9 by 3, you get 3. Then you can ask if any other numbers are in common here. 2 and 5 are not, and 3 and 5 are not, 2 and 3 are not. So you're actually all done there. So then what we're actually going to be doing is we're going to be going 3 times 2 is 6 over 5 times 1 is 5. So here we're going to be simplifying before we actually multiply. So we're going a little bit backwards from what you might have done, where you might have multiplied first and then reduced. So here we're reducing, then multiplying. So it's really nice in these kinds of terms where you don't have to look for a number in common anymore. You already see them broken down to their factors, and it's a lot easier to see the numbers in common with 9 and 3, rather if you went 18 over 15. And we're going to use this technique for simplifying or multiplying rational expressions. So just as a quick note here, you should do not ever expand your brackets until you have fully simplified and canceled all of your common terms. That way you can make sure you've left your answer in its simplest terms and don't end up running into any errors there. So we're going to practice this concept using example number 3 from your notes. So here we're going to state the non-permissible values, then we're going to simplify the following rational expression. So here we have y squared minus 9 over r cubed minus r times r squared minus r over y plus 3. So the first step here is we're going to list our non-permissible values, which is the same thing as those restrictions. So just like we did in the last video, we need to look at our denominators and set them equal to 0 to find out what values for r and y would make the denominator 0. So we're looking at our first fraction here, which is r cubed minus r. We're going to set that equal to 0. That way we find what values for r would make that expression 0. So when you're dealing with two terms, and here we have a cubed term, that's kind of really gross, but one thing you'll notice is that here we have an r value in our first term, we have an r in our second term. So if we pull out a common factor of r, what we find is that we have r squared minus 1 left over. So that looks a little bit less gross than working with r cubed. So then what you can notice is we still don't have our factors broken down. We still have an r squared term here. So what we can do is we can factor r squared minus 1, or what you would notice is that r squared and 1 are both perfect squares, and the operation here is subtraction, so this is the difference of squares. So with the difference of squares, you're going to write your two brackets. Make sure you still bring down your r value. You haven't actually done anything with that, so make sure you write it out front. So when you're doing a difference of squares, you square root your first term. So square root of r squared is r, and that goes on the left side of inside the brackets. Then you square root the second term, so square root of 1 is just 1. And then 1 gets a plus sign, 1 gets a minus sign. So that there was your difference of squares method. So now that r has been broken down to each of its different factors, now we can set each of those equal to 0. So our first one here is just the r value. So r is equal to 0 would make that 0. Then we can look at our second factor. Then we have r plus 1 is equal to 0. So we want to subtract 1 on each side to get r by itself. So r is equal to negative 1. Looking at our third factor, we have r minus 1 is equal to 0. So solving for r, we're going to add 1 on each side. So we get r is equal to positive 1. So those are all your values for r. So you could say that r cannot equal 0, negative 1, or positive 1. If r is any of those values, then you would get an undefined or an error if you had to put that into your calculator. So now we need to look at our second fraction. And this one here, we're actually dealing with a different variable. So here we're working with y plus 3. So this one here, we're already left with just a y value, which is really awesome. So all we have to do is we just solve for y. So we're going to subtract 3 on each side. And we find that y is equal to negative 3. So then your restriction for y is that y cannot equal negative 3. And these here are your restrictions for this entire equation. So we have r cannot equal 0, negative 1, or 1, and y cannot equal negative 3. So with this said, I just want to make sure that this is clear. R and y are different variables, so r can be negative 3, but y can't be negative 3. Y could be 0, 1, or negative 1, but r cannot be. So they're two separate variables, so you have to do two separate restrictions for them. So you can't write them in the same little expression like we did for this r value. So now that we have stated our non-permissible values or those restrictions, now we can go ahead and simplify the rational expression that we're given. All right, so now we're going to simplify. And I'm just going to start off by just rewriting that question there. So we had y squared minus 9 over r cubed minus r. Now it's multiplying with r squared minus r over y plus 3. All right, so our first step here is we want to multiply those two numerators together, and we want to multiply those two denominators together, just like what we did with our regular fractions. So you have y squared minus 9 times r squared minus r all over r cubed minus r and y plus 3. So essentially what we're doing is right now we're really looking at that 6.1 lesson where we're really just working with simplifying the rational expressions. So all we have to do is break this into its factors and then just cancel out anything that's in common. So looking at our first term here, we have y squared minus 9. So to break that into the factor, once again, you guys will notice that y squared and 9 are both perfect squares, and they're being separated with a subtract symbol. So this is a difference of squares. So start by drawing your two fractions, or your two brackets, sorry. Then you square root your first term. So square root of y squared is just y, and that goes on the left side of the brackets. Then you square root the second term, so square root of 9 is 3, and that goes on the right side. Then one gets a plus sign, one gets a minus sign. So now we've broken y squared minus 9 to its factors. We could do the same thing here for r squared minus r. And if you notice here, we have the two common factors here. So we're pulling a common factor of r, and we're left with r minus 1. So far our numerator is y plus 3 times y minus 3 times r minus 1. Then we can simplify our denominator, and we actually don't have to do the work for that one because we've already done that in our restrictions. So if I go up to the top, I can see how we simplified the denominator. So here we had r times r plus 1 times r minus 1. And then our second fraction was just y plus 3. So we didn't actually have to simplify that one. So I'm going to replace our whole denominator with what we broke it down to. So that was r times r minus 1 times r plus 1. And then we had y plus 3. So now that we have everything broken down to its factors, it's as simple as it can get. Now we can actually cross out those common factors. So I'm going to start off, I usually just go to the left in my numerator and work my way to the right. So I want to ask myself, is there a y plus 3 in the denominator? So going through here, I do. So I'm going to cross that one out and cross it out up top too. Moving over to y minus 3. Looking down here at the denominator, there is no y minus 3, so I have to leave it. Then I move over to r. Is there just an r in the denominator? And that's the first one there, so cross those two out. Then we will look at r minus 1. So r minus 1, it is the second term there, so cancel those ones out. So all that we're left with is we have y minus 3 up top, and we have a r plus 1 on the bottom. So you cannot simplify that fraction anymore. So up to this point, we are all done. We've stated our non-permissible values and simplified the rational expressions. So that is everything for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.